I'm discuss with you about how to implement the digital camera design. What is our target device? Which language is the we have been used for implementation of digital camera? Here, this is I used a Cool Runner 2 family XC2 C384. Speed is -7. Tool is Webpack 14.7 and the language is VHDL. Here the list of the files or the modules here have been used, the rest of inputs and outputs, and IOS is the SRAM data, because here the data image has to be stored in the SRAM, and as well as it has to be seen on the LCD panel of the camera, which image we have been taken up. For this I have been used I2C modules here have been used to transfer the data from LCD control panel to the SRAM memory. Anyhow, for initially we will have a little bit of discussion about the digital camera, the block diagram of the camera, everything. Here we have two types of image sensors. We have one is charge coupled device, the other one is CMOS image sensor. I have used CMOS image sensor from Micron Technology Inc. The image sensor I use here is CIF-size to 1.3 megapixel sensors. Now I can show you the block diagram of the digital camera. Here are the few blocks of the camera. One is main control logic, SRAM interface logic, CMOS image sensor, image grabber, control logic, LCD interface control logic, LCD panel, inverter, PWM logic, all these things. Here I give a brief description. When the CMOS image sensor gets the signal to saying that get the image file from shift interface control logic, CMOS image center image grab the image and sends to the image grabber control logic to saying that get frame data flag. It asserts the frame data flag. Once the image grabber logic has captured the image and it stores in the SRAM memory through SRAM interfacing logic. Well, once it has stored the image, we have to see that image on our LCD panel of the device. For that, here we are going to see that LCD interface control logic from SRAM. Through LCD panel, and it works again through PWM logic. These are the main blocks of the digital camera. Now let us share the screen. Sorry. This is the main block diagram. This is the main module of the digital camera. Here it has the inputs of data, line, frame size, preset, number of pixels. As I said, I used I2C for communicating the image data from LCD to SRAM memory, LCD block to SRAM memory. So these are the I2C data signals for that. This is the horizontal sync and vertical sync of the LCD panel. LCD red, green, blue. I have used RGB colors. We know we have to use RGB, the standard color signal. And the right, left control, up, down and control buttons of the LCD. DC link board button, and that is the clock of the DC link. And SRAM signals enable output, enable, write, enable data address of the to store the data in the SRAM, and again it to read it back again. These are the main signals, inputs and outputs of the digital camera. This is the image grabber file. Here, when, as we said, when the get frame data and get data done, it has to images. Once the image has grabbed from the image sensors and it sends through the image grabber file. Once it has done, get frame data is asserted. Once it is done, get data is asserted, and it has sensors, image sensors. I used Micron Technology, so we used the signals MI data and line value. These are the Micron image signals, and addresses, and it sends through SRAM memory through a image grabber file. So IG and SRAM data to write the address of the image, shipping to interface the file, shipping in system reset pixel clock of the camera, I2C block. This is LCD interface, LCD control panel. It has horizontal synchronizing and vertical synchronization, RGB colors, as we discussed earlier on the main file. All the start, done, reset, address and PWM logic, everything here. So anyhow, we will see the implementation. I'll go for implementing the design. Save as. Now let us see the summary report. This is summary report. No errors and 68 warnings. This is CPLD filter report. This is the utilization of the CPLD. Macro cells is utilized at 63%, PDOMs 39%, the registers are 58%, and total pins we have used is 65%. Total function block of inputs used is 55%, the total usage of the CPLD. Now I'll show you RTL schematic diagram of digital camera. This is RTL schematic diagram of the digital camera, and we go for technology schematic diagram as well. This is the technology schematic diagram. Now we go for simulation, behavioral check syntax. Simulate behavioral model. simulation, run all, simulation, break, zoom it, this is the image, these signals are the image sensor signals, data, line, valid, frame, pixels, and all things. These are the LCD signals, and these are the memory signals of SRAM. Stop. This is a way we have implemented digital camera, and I showed you the simulation, all the schematic and technology diagrams. Please see my videos from Sudha Technologies. You can anytime you can download this project from Sudha Technologies. Thank you. Have a nice time. Bye.